你们都好吗？这是 Michael， 我很高兴欢迎你们再来看深圳 IO。今天我们要 Nah, I'm just joking. We're not going to do it in Chinese today, guys. In fact, I don't think I have the ability. It's been forever since I've even really spoken it. So we're back with SHENZHEN I, which is just an incredibly awesome game. Apparently there's been an update, and I'm not sure exactly what changed. It looked like pretty minor stuff, although there is some more information on the part not sleeping error that we've gotten at various times. So, we have two options here. We've got infrared sensor and we have bring out the Baron. Now, we haven't looked at either of these, so I don't know what's in them. I might pause and take a look. So here we've got our bring out the Baron drinking game scorekeeper. We've got two inputs, point and foul. Simple inputs connected to buttons. Display is an XBus output connected to a numerical display. Counter should keep track of a count starting at 0 and then constantly update display with the current value. When point transitions from low to high, the count should be incremented. When foul transitions from low to high, the count should be decremented. Alright, and so we've got our output here, 0, 0, 1, 1, blah, 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 as the buttons are working. So we need a microcontroller for each of these buttons, I believe, and I did experiment with this a little earlier because I wasn't quite figuring out how to coordinate between multiple devices, but now I think I understand how they work. So if we connect up like this and that. Alright, so here's our X bus going across. We've got our regular just a 1-bit input going in and going out into this one, coming from foul through this guy and into here. So what we need to do is test P1 or P0, our input, and if it has changed, we need to update the accumulator. So test equals P0 ACC. So we're going to test the value in P0 against the accumulator. And if it is actually not true, if it is false, if it's not equal to the accumulator, then we want to move the value in P0 to the accumulator. And then we want to move that value to P1. Move accumulator to P1. And then we need a false condition here. What are we going to do if it's a false condition? I think what we're going to do... So false could be it was a 0. Goodness. Now I'm confused. Test equals P0 to accumulator. Okay, we're testing the P0 to the accumulator, then we're moving the value to the accumulator if it is false. So if they're not equal, we're moving it. So that would imply that a change had happened, and if the change has happened, then we do want to move it to P1. So it was going to be either putting 100 out there, or it's going to be putting a 0 out there if it is changed. But if it's not changed, we actually don't want it to, we want it to just send a 0 across, because what we're going to be looking for on P1 over here is for 100 value, right? So when it changes to 100, it'll output 100. When it changes to 0, it'll output 0. But when it doesn't change, what are we going to output? I think we move 0 to the output. So move 0 to P1. And then we sleep for 1. But I'll show you what's wrong with this code in a minute. Okay, so we're going to do the exact same thing here. We don't even have to modify the code. So if foul or point is a 100, if the button is pushed, we're going to, when the button is pushed, the very first instance that button is pushed, we're going to put it into the accumulator and we're going to move the accumulator in over here, no matter whether it's a 0 or a 1. So actually, We're also going to put it across when it changes state, I guess is what I'm saying. And then any other time we're going to just output 0 onto P1 and P0. So over here we need to read them. So let's start with the point value. So we're going to test equal P1 to 100. So that is if the button has just changed state to being pressed. We don't care if it's 0, we only care if it's 100. And if it is 100, then we are going to need to add 1 to the accumulator. Otherwise, we don't need to do anything, actually. And then we're also going to test equals P0 to 100. And if that is 100, then we're going to subtract 1 from it. Now let's, and then we need to sleep 1. So let's see how this works. So if I do step, we go to our first instruction over here and we test against this button. And we step again, it failed because there was no change. It was 0. Both these inputs were 0 and the accumulator was 0. And now, so we're moving 0 onto the P1 bus. But look what happened over here. We went ahead and advanced 2. We went ahead and checked P1. And now we're checking P0 over here. And that's going to fail. So keep stepping. And now we're on sleep 1 for everybody. And we go to the next cycle. But see, we failed because we didn't actually, well, okay. Let me put one more thing in here. We need to actually output this thing now. So we need to output the accumulator to X1. So move ACC X1. Right. Let's try it again. So we're going to step. Test failed, so we're going to move 0 onto P1 from both of these first microprocessors. But we're already testing. We've already tested P1, and now we're going to test P0. So those are going to fail, and then we're going to move the accumulator to X1. Why is it... oh, because I put it after the sleep. Oh my goodness. Can't get right over here. Let's put it after that. Sleep 1. Okay, one more time. Okay, we're now moving the value onto this output, but we're already have tested this one, and now we're testing this one, and we haven't even gotten the data yet. And then we're moving the accumulator to the display. It's a 0, and there you go. So we passed the first test. And if we step through again, we're going to send another 0. So we passed the second. But now the value has changed. So look here, what's going on. We've now fallen through into this condition, the not true condition. It's not the same as the accumulator anymore. So now we're going to move the value of P1 into, or I'm sorry, we're going to move the value of P0 into the accumulator over here, and then we're going to move the accumulator onto P1. But the accumulator, or this microprocessor, is no longer even listening to P1 because it's already moved through its set of instructions. And so when it comes time to move this value into here, we've already moved a 0 into there. So what we need to do is, and I didn't think of this at first, is there's a command called NOP, no operator. And what we need to do is to sort of space this out. See, this is executing line for line with everything. Everything is executing at the same time. But what we need to do is make this guy wait for however long this guy is doing stuff over here. And so each of these is doing stuff for, it's testing equals. It is moving the value of the line into the accumulator, and then it's moving the accumulator onto P1. So that's 3 instructions right there. So we're going to have to wait over here for 3 instructions. So NOP, NOP, NOP. So there we go, and I think we're full up on code over here. And then the other thing that we have to do is, if we look at this, this actually is only 1 instruction versus 2 here. So we need to also put in another, in the positive condition, we need to put in a NOP and wait. so that these little branches of code are the same length. It's going to take 3 instructions to execute this, 3 instructions to execute this. And we're waiting for 3 instructions, and then we check the port. And I think this is going to get it for us, so let's try. So we're checking the values over here, and we're doing nothing over here. We are now, the value is the same as, so we're just moving 0 onto P1, and we're doing nothing over here. Same thing down here. Here, we're just waiting, and we're waiting over here. And then now we're going to look at P1 and see what this is. And it wasn't 100. And we're going to check P0, and it wasn't 100. Now see, these are just waiting at the sleep, right? And now we're going to move the accumulator into X1, which will be 0. And it's going to light up our display, and we pass the first time step. So we do that again. Same thing is going to happen, but let's see what happens now that the button state is changing. So on this one, we're going to get a true condition this time, and you can see that it's already, well, no, actually it hasn't. I'm sorry, we get a false condition, pardon me. We get a false condition because this value is different than the accumulator. So now we're going to move the value of this input to the accumulator. It becomes 100. And now we're going to move the accumulator onto P1. So now we're putting 100 onto P1. And notice that now we're ready to execute this step, which is testing whether P1 is 100 or not. And it is. So we're going to add 1 to the accumulator. Now the accumulator is equal to 1. We're going to test P0, see if it's 100, and it's not, so we fall through. And now we're going to move the accumulator onto X1, and the accumulator is currently 1. So our display flips to 1, and we pass the condition. And I believe that we are going to pass all of these conditions. Yep, we got it working. So it counts up when when point is pushed, it counts down when foul is pushed, and we have solved the puzzle. So NOP is your friend. I didn't even realize how these things were executing in lockstep. Although it makes perfect sense, right? There's no reason for this guy to be waiting for this guy. So it has finished the simulation, and I have no idea still what this really means, but whatever, it's fine. So don't remember the actual rules. If you can't remember the rules of the game you're playing, how can you be sure you actually made the deal? Because they sent us a case with a variety of flavors. It's very tasty stuff. Come try some. Carl Teskey says, it's already too late for me, but you can still save yourselves. Heed my warning. Do not drink the Baron von Schnapps. Bye then. See you in the next life. Okay. So we have passed the test. Tilly is back. Hey, y'all, you all, yeehaw. Okay, well, let's look at this, actually, because it's got some Chinese in it. For a totally random example, SHENZHEN. How do you say it? What's that ZH doing in there? Can you just ignore it? Spoiler warning, you can't. ZH is its own sounding Chinese. We don't have time to go into all the fun foibles of pinyin. Pinyin is the romanization, how you turn Chinese characters into English, and there's a couple different ways to do it. There's the old sort of Quang Tong, Wade Giles method, and then there's the Gale method of pinyin, which is more, I think, closer to the way Americans would say it anyway. I don't know about the Brits. The official romanization for Mandarin Chinese, let me just give you a little shortcut. Say SHENZHEN, like you're talking to your best friend Jen. Well, it's not SHENZHEN. And you're probably closer than you were before. How's that for confidence? Do you one better? The Chinese yuan is the currency here. The word is one syllable. Yuan or yuan. That's kind of painful. I'm not sure how to fix this quickly. How about saying yuan really quickly? Yeah. Okay. Japanese yen, Canadian dollars, blah, blah, blah. Anyway, whatever. So Chinese yuan. Passive infrared sensor. Infrared sensor, important. I'm in the process of setting closer tie-ups with top global firms and am working to secure higher profile work for our company. First result of these efforts is the contract to create an infrared sensor. This allows us to participate in the booming market for passive monitoring stations to detect illegal activities, illegal carbon emissions, illegal growing operations, illegal immigration. If it's against the law and it generates heat, we will detect it. Okay? Excuse me. Pardon me, I seem to have caught a bug. No worries, just swallowed a fly. Okay, so we got prototyping new ideas and virtual reality buzzer down here too, but let's take a look at this infrared sensor and see if we can make a heads or tails of it at all. Okay, what do we got here? RTC is a simple input connected to a DT2415 real-time clock module. So here's our clock module up here. Sensor is a simple input connected to an infrared sensor. Alarm is a simple output connected to a silent alarm. Okay, it's over here. The alarm should be turned on whenever the sensor reads at or above 20 between the specified on and off times. The on and off times are set by the operator using switches that can be read as X-bus inputs and use numerical values compatible with the DT2415. Oh my goodness, what? All right, let's see. RTC sample input. The RTC is a clock. The sensor simple input, okay, goes up and down. The alarm simple input is output. Okay, this is when we should be triggering, right? So, yeah, I don't even know. A simple input connected to a DT2415 real-time clock module. Okay. So this is our input. So let's see what happens if we just put this here. Pin type mismatch. Oh, okay, because it's a simple. We need it to go there, right? Sensor is a simple input connected to an infrared sensor. Okay. Okay, well we can see we're going to need at least a couple outputs over here. So we're going to have like that maybe. And then these guys are X-bus modules. They look like ends to me. Can we connect you here? Okay, we can. Alright, I'll tell you what, it looks like we need a lot of X-bus connections. So let's try instead this MC6000 and take a look at that. This one we might have to delay finishing this guy until the next episode though. Alright, so you're a simple input. So we're going to need we're going to need a guy to control or to take in this time over here. No, right? Yep. You want to go down here. All right, good deal. So now we have a whole bunch of X-bus inputs. We could do it like that, do that like that, do that like that, and then we got to take in these off times over here, on and off times. I think maybe I have to rewire this a little bit. Like that, perhaps. You're going to go to P1, and then I can bring this guy around here like that, and I can bring this guy around here like that, and that guy there. Maybe that works. I'm not sure. Okay, so we got our sensor input coming in here. We got our RTC coming in here. What do we need to sort of coordinate? Sensor is a simple input connected to infrared sensor. Alarm is a simple output connected to silent alarm. Okay, those two are fairly easy. We're going to be looking at the sensor, but we're going to be comparing it to the clock. we're going to be comparing this clock output to these things. So it seems to me actually like we need the clock to be inputting up here, don't we? Can we move these? Oh, we can move these. I didn't realize. I thought they were stuck there. Maybe we don't need this fancy gadget. Maybe we don't. Let me go work on a layout for this and come back in a sec. Okay, I think maybe this has got it. It looks a little convoluted, but let's follow the chain here. So we got a clock here, and we have an on time and an off time. So if we bring the clock in here and we look at the on and off times, we can figure out whether or not we're within the right range. And if we're in the right range, we can send a signal down here to this guy who will do nothing as far as I can tell except pass it on, but we need that because we don't have another X1 over here, right? Or we don't have another X bus on this guy. So I think we need this part just to be an X bus. So it's just going to pass through, I think, into here, and then so we can check X0 to know whether we're in the right time range. And if we are in the right time range and the sensor is above a certain amount, then we can output it. Is there a better way to do it? I think there might be, because I'm not sure we can do both of these tests in the same one. Yeah, I don't know any other way but to try it. So let me go develop some code and see if we can get this thing to work. If not, I hate to leave it open-ended, but we might have to come back to it. So give me just a sec to try it out. Okay, guys, I'm going to admit to being stumped on this one. I did a couple things here. I tried a few different configurations. The problem with this MC6000 is it only has two simple inputs, right? So we have one simple input here, one simple input here, one simple output there. So we need three. So we're going to need at least one more module. So I threw this one in here, and all I did was take the input and put it onto the X1 bus, which comes over to here. Here I have to perform a no operation so that this can have it on the bus and ready, and then we read it from the bus. And what we're doing first here is testing that it is less than 20. If it is less than 20, we jump down here to the end and just cancel what we're doing. So if we run that, we'll see that it's only a 12 here. And we're just going to skip doing anything else and jump to the end, and we're going to move on to the next one. Right? So again, it's 10. So this is our main condition. If the sensor is not reading above 20, then we're not even going to bother with it. 20 or above, excuse me. We're not even going to bother with it. So now it's 48. So let's see what happens when it's 48. We're going to step through. So we pass that test and we don't jump to the end now. Now here comes the problem in testing the time, though. At least in here, in the way I'm doing it, is that we have to test that it is after the start time and before, after the on time, before the off time. But the problem is that the off time starts at 93, or the on time starts at 93. The off time ends at 20, right? So we can't just test that it is like within this range by saying if we're less than on time, because we're going to get the values above 20 but below 93. So we really have to test that it is greater than on time and less than off time, at least in this case. And actually this wouldn't work if you were going to change the on and off times. And then the next problem is that the times here are specific. So 93, when we advance through this, we're going to get up to close to the time right here. It's 93 is the on time, and that is what our clock is reading, is 93. But so now we have to test not only that it's greater than this, we also have to test whether it's equal to that, because it's greater than or equal, and there is no greater than or equal operator, unfortunately. So there's too many comparisons here. I've put it in as we're testing that it's greater than, and if it's not, we jump to the end. But then I'm testing that it's equal. So the problem is that, okay, we'll just run through it here. Is it greater than? No. So we jump to the end. Well, we've skipped looking at whether it's equal to. There's no way to make nested conditionals, so I don't know exactly how to solve this guy. So let me go play with it. It's just a matter of me trying to figure out how you're supposed to do things in this, and I think it probably needs like another module to do the time figuring or something, and then input that into here. But in my couple of little tests on that, I wasn't quite able to figure it out. So I'm going to claim failure on this one, guys, and we'll come back to it. So I will see you next time around. Thanks for joining me, and have a good day, night, morning, whatever it is where you are that isn't Shenzhen. See ya. Bye.